Hello, hi everyone. I'm Lin Lin. I'm from Shanghai Astronomical Observatory, and I'm the last one. I would like to talk about something beautiful and simple, and I would like to talk about the bar-induced central star formation enhancement. And so, first, we know bar galaxies are very common in local universe, and from local disk galaxies, bar galaxies are 1/3 of local disk galaxies. And when we account the weak bar galaxies, or we count bar galaxies from near-infrared imagery, the Bach fraction is higher. So bars is believed to be the key driver of secular evolution of the local universe, and the theoretical of bar-driven secular evolution is to say, bars can, when bar rotates, and it can transfer the angular momentum to outer disk, so the gas will inflow along the bar, and this is a natural sequence. So, and here shows an old simulation, and it shows the gas pack. It shows after several rotations of bar, the gas particles will surrounded in the range, and so observations estimate the central star formation rate in the central region, and the star formation rate due to the bar are higher enough to build up a pseudobulge in a few giga-years. So on the other hand, the existence of a bar will change the looks of several classical bulge. Several observation evidence shows that the secular evolution built pseudobulge can coexist with a classical bulge. And here shows two examples. And when we look at the images with very high resolution, we can see in a very central region there are spiral-like, disc-like structure in the central region. And evidence also comes from the measurements of stellar velocity dispersion. And we can see in the inner region, and the sigmas are higher and indicated they are dominated by random motion. And where we can see in the very inner region, there is a sigma drop in the center. So it suggests that there is a disk-like rotation component in the center. So the studies of bar-induced central star formation has been carried out for a very long time, and a lot of evidence shows bar can induce central star formation. And here shows the compare with bar galaxies and unbar galaxies. Bar galaxies will have a systematically higher gas concentration compared with unbar galaxies. And also, here shows a statistic work from SDSS central spectrum. And we can see in low mass and galaxies, age of the central bulge, their distribution of bar galaxies and unbar galaxies, they are similar. But where we can see in the higher mass end, the bar galaxies has a bimodal distribution in their central bulge. So it suggests that bar are correlated with quite a large fraction of central young stellar population. And on the other hand, if we try to find what kind of galaxies will have higher central star formation enhancement, we can see a lot of fraction galaxies shows central star formation enhancement. They are bar galaxies. So that is was to point out that the previous works are limited by spatial resolution. Most of them are from results of SDSS survey, and they are, or some of them are limited by sample size. So that is why we need large sample IFU survey. We can know detailed things to study the correlation between bar and bulge. So here shows our study. We analyze galaxies in Califar survey, and Califar is a very nearby galaxy survey and target of about 600 nearby galaxies. And when we start this work, it has released 200 galaxies. Oh, okay. And we select the phase-on spiral galaxies, and we have done very detailed full spectral fitting and photometric decomposition. So our aim is to trace the recent star formation history of bar galaxies and unbar galaxies, and we choose 3 star formation history indicator to reproduce, to investigate their star formation. These 3 indicators can trace the recent star formation because it's due to they are sensitive to different time scale of star formation history. So here shows the D4000 index. They are sensitive to older star formation, and H delta equivalent with peak at post-starburst, and H alpha emission are trace the current star formation. And here shows our results. And typically, when we look at spiral galaxies, their central are dominated by old stellar population, and outer disk are we can see there are many H alpha emission, and they are dominated by young stellar population. But the most interesting thing is we find a kind of galaxies they have shown. We call them turnover galaxies. They have shown turnovers in the very inner region, and in the D4000 and H alpha equivalent with their profile central region have a turnover in the central. So we use a straight line to fit the profile. So the idea is when we compare the observed central value versus the extrapolated central value, we can choose pick up these turnover galaxies. So here's our result. We compared those 2 observed and extrapolated value. So we indeed see a population of them that show lower D4000, which indicated young stellar population in the central. And as we have 3 indicators, we can see the other 2. And so result is most of them are show turnover in 3 kind of indicators simultaneously. And come back to the first plot, we can see those blue triangles, they are bar galaxies, and red circles, they are unbar galaxies. So our result is we can see most of the turnover galaxies, they are bar galaxies, but while we look at the whole bar galaxy sample, only half of the bar galaxies in our sample, they are turnovers. Next, we use 2 parameters, the turnover size and delta D4000, to quantify the strength of turnover. And we are trying to find what kind of property will correlated with turnovers. So I have to say our current sample are limited by sample size, so we can see very weak correlation in bar length and from the H1 fraction, and while we don't see very clear correlation with bar galaxies. So this is the next last plot, and as I say, D4000 and H delta, they are chase different time scales star formation history. So when we combine those 2, we can know what kind of star formation history they have experienced. here shows the background curve are a model curve from different tau model, and the short tau are similar to starburst star formation history, and a larger tau means the star formation history are quite constant. So we highlight those turnovers are in the right panel, and one is the extrapolate value they're supposed to be if they don't show turnover, and the others are observed values. So we can see if they are not turnover, we can see a shift. Their star formation history are quite consistent with continuous star formation history. So my summary is we identify some turnover galaxies, and our main conclusion is most of turnover galaxies we find are bar galaxies, but the whole bar galaxies, only half of them show turnovers. Okay, thank you. I stop here. Yeah, I maybe, I have this plot. Oh, sorry. If you are interested, here shows a central BPT diagram, and the symbols with larger circles, black circles, are turnovers. So quite a fraction of them are central star formation, and several of them located in the linear region. The result of the central spatial.